This week we continue on UML models. So we start with the first diagram is a sequence diagram, and that's also part of your this week's lab and part of your term project. So we know the sequence diagram is a representation of behavior as a series of sequential steps over time. So from here, we see that there's an object and the actor are placed in the diagram horizontally, and also the message and send it back forth horizontally, but the time is arranged vertically. So the element, each element, so we're talking about element here, the actor, object, and classes have a dashed stem called lifeline. It shows that one is the start and the one is element being destroyed. So let's skip this the definition. Let's go directly to the example, and this will make more sense to start with. So this is an example of sequence diagram for staff to save a contact in the contact table. We can say what database, and then you see this element has different shape. They look differently. And we will discuss that later. Yeah, because the first one has a vertical line with a circle is called a boundary, and this one with a circle with an arrow, and this we call the control and the control object, and the one has a horizontal line we call the entity object. So this boundary, just by its name, we know is used to interact with the user. So here the user is a staff member, and his job is to insert the contact into the contact table. And then in order to do that, it must, the staff member, you must provide some kind of interface. Is a web interface or standalone interface for the staff member to interact. So the first interface we call the view contact list. And then yes, so for this one to be shown, then it's called create contact method, and this method is part of view contact list. So when you call this method, and this window is showing up, and then the staff can click on the create contact button. So you can imagine that this one has a create contact button. When you click on that button, it will forward the request to the contact manager. So please keep in mind that for every boundary, so you can consider boundary object as an interface. For the interface, there's a control unit behind to take the response and to validate the response from the user. And some of the validation of the input can be validated by the boundary element itself. For example, like when you are asked to enter the date, yeah, we know that every month has only up to 31 days. If you enter 32, then usually the interface will catch that error and give you, okay, you enter the wrong date. And how this interface knows? There must be a code behind to do the validation. So for this, simple validation can be done by the boundary object itself, but some complicated one, negative verify with the database to see if you enter if your username and the password combination is right. For this kind of validation must be handled by a separate object, or like if you click on a button and this button usually will call the operation of another object. So you can see that is for a boundary object, there's always a control object behind to handle the interaction. So in this case, behind this view contact list, we have this contact manager is to coordinate with different interface. So this is create. So when you click on here, the create contact. So this contact manager take the response and then we'll open a new window. So imagine this new window is for the staff to enter the contact detail information like a name, email address, something like that. So this added contact is another boundary object for the staff member to enter the detailed information. So once the staff member enter all the required uh, information, then he click on the save the button, and this save the button, the request is also forward to the contact manager. So think about this contact manager before do the saving will validate the input, and then to do the saving. Okay, so once the actual saving occurred, uh, should this contact manager directly save the information into the database, or we need another object to handle, I mean, to I mean, just interact with the database? The answer is yes. If you take in the OO design, we know that in the OO design, there's a principle called maximize the cohesion and minimize the coupling. The maximize the cohesion shows that one is better for one object just to take one kind of responsibility. Don't be too diverse. So if you keep that principle in mind, we notice a contact manager is to coordinate, is to control with the boundary interface, and then interact with the data is a whole different kind of responsibility. If we put these two different responsibility into one object, then the cohesion of this object is very low. And also we increase the coupling because this object will interact with so many different kind of object, and this one is highly coupled with others. So in order to increase the cohesion and decrease the coupling, it's better to assign this data interaction to to a different object. So that's what we call the persistent manager. And this one has only one job, is to interact with the data. For example, you can think of this one is a database. If you learn the database course before, then you know that to interact with the database, you need to run the query to connect with database and run different queries. So that's a totally different responsibility than just interact with the interface. The user interface. So here we have a persistent manager to handle all the interaction with the data. So the make persist request is forwarded to the persistent manager, and then it will insert data into the database. So this example is a very typical sequence diagram, and I want you to dig into this sequence diagram, and your sequence diagram in your lab and your term project should very much similar like this, as must contain boundary, control, and the data. Yeah. So when you think of the control, please keep in mind that it's better for one control just to do one kind of job. Don't put too much different responsibility into one control unit. Okay, this is the first example, and here is another example. So this shows that the customer, okay, place an order and illustrate the payment process. So from here you can see that this order screen is a boundary object for customer to get the order information. Okay, and then here is a shopping cart, and this one is not, is unlike any other shape. So this one is you can say, usually we have a boundary control an object. If you cannot classify the object into any of this category, you can just leave as it is. So this one shows that it's unclassified. It doesn't belong to any category. So this is a shopping cart, And then within the shopping cart, this consists of the shopping cart item. Uh, so your customer choose item, then it will create a new item in the cart in the cart item. So this new shows that this cart item just being created is a new one. I mean, it's not exist the same time as a shopping cart and order and the payment object. And this one is created only one customer click on that, I mean, item. So an item being created and this one is being added into this shopping cart. So once this item is in the shopping cart and the one will be deleted for, I mean, because you can consider this one is like a temporary. Yeah, it's a temporary item. Once it's confirmed, it's being erased from the memory. Okay, then the next is to get the parents. So this shows that so keep in mind that in this order contain multiple items. You calculate the total cost and showing to this order screen window so the customer can see the can see, I mean, the total cost. The last is to make a payment and confirm the payment. So this shows that compared with the previous one, this one is a little bit more complicated. One is you have some uncategorized items, and also here you can create new item. And I mean, this item is not, I mean, that does not exist from the very beginning. It's being created. So here, this is new. You can imagine that when you create a new object, when you create a new object, so you can translate this one into I mean the code as a new object, and also you can destroy the object. Okay, so here we have a two typical example, one involving the data and the other involving data and showing the new object and the destruction of the object as well. So from the previous two examples, we see that the object has three types: the entity, boundary, and the control. The entity object represents so you consider the data, represent the data. The boundary represents the interaction between the user and the system. So you can imagine this one is like a user interface, object. Control object represents the control task performed by the system. This one is usually behind. You can think of like the control object is like your nerve system, like your brain is used to coordinate the entity and the boundary and with the actors. So this shows the differences of boundary, entity, and the control object and the detail. And we'll skip this because we already seen them in two examples. Okay, let's working on this exercise. So here we have a different object and I put them in category already, and please help to map this into the boundary, control, and object. So here we have year, month, and date, change date, we have a button and LCD display. Yeah. The first one is entity object, it's talking about the data. The second one is a control object, change the date. The last one, button and LCD, is a part of the interface. So this is an interface object or boundary object. Message. So the message in the sequence diagram is actually a function call. So displayed as an arrow, message can be complete, lost, or found, or synchronous, or asynchronous, call, or signal. So most of the message you've seen in our previous two examples are synchronous message, which means when you call and you got the return immediately, and asynchronous means when you call this one and then the result may come back later. So that's why it's called asynchronous. You don't got the result. You don't got the return message immediately. So here we see the example here. The first one is asynchronous, and then you'll see that the message, the arrowhead is different. It's a solid triangle. And the second one is asynchronous. See this open arrow. So and then this one is called a return message. So you will see that usually a synchronous message come with a return message because when you have this asynchronous function call, you don't get the result, and the result has certain delay for various of reasons. The response will take time to arrive. Self-message. Self-message represents the recursive call, uh, and and also you can have you can call itself. It's like a within an object. One method call another object, call another method in the same object. So this is we call a self-message. Recurve means this calling happen multiple times. Recursive message. Lost and found. The lost message means this message doesn't have a specific receiver, and the found message shows that this message doesn't have a specific sender, so or unknown sender. So here, if the sender or receiver is not clear, then in the sequence diagram, the message can be lost and found. Okay, in our example 2, we shows that the message with an object can be created, and also you can delete an object. So accordingly, the message is a new message, and delete. The new is to create a new object, and the delete is to destruct an object. Duration and time constraint. So by default, the message is shown as a horizontal line. So horizontal means there's no delay in the message delivery itself. So think about the function call. So when you call a method, then that method will be called immediately. So even the result may take time to get, but the message itself, the function call itself, is happen immediately. So that's so so that's why in the sequence diagram, the message most of the time is a horizontal line, shows that it's taken no time for this message to arrive. However, in some situation, especially like a distributed system, the object, uh, you have a call over the internet, and then if for the function call itself will take time to arrive. In that case, we call the duration and time constraint of the message. And here is that this message is not horizontal line anymore. It's a line going down a little bit, showing that this call will take more than 10 milliseconds to arrive. And the reply will also take like more than 5 minutes to arrive. So even the target already, give you the answer, and the answer will take time to arrive. So this is, but most of the time this won't happen but in some scenario, if this really a quite distributed system, and this function call across the internet or across different network will take time, then this you can show that differences in the in the sequence diagram by adding this time constraint and duration. Then let's see, then object can have more than one lifeline, and here we show the different port. So this allows the inter and intra object message to be displayed on the same diagram. If one object is kind of quite complicated and provide uh, like a different category of operations. So usually, if that's the case, in the OO design, we separate them into the two objects, and one just handle one kind of operations, so that's to increase the cohesion. But in the analysis level, or even in the in the domain level, some object can be quite complicated, or some and in analysis level, some classes in the future can become multiple classes. But in the analysis level, they belong to one subsystem or one component. If that's the case, you will see that one component or one subsystems, they have like unrelated uh, operations, but they all belong to one component or one subsystem. If that's the case, we can have this part decomposition. Okay, this one class is super big, contain different interface, and this different interface will interact with different object, and between them they can also send a message back and forth. So this the sequence diagram can also represent that. So one class or one subsystem quite complicated. You can have multiple ports, and each port will represent one functionality, and one interface this class or this subsystem represent. Okay, let's look at the example I have from last week. So last week we had this class diagram. And then I want to show you how I draw a sequence diagram to represent this use case. So I explain how I come up with this class diagram. Then I will see that then we'll draw the sequence diagram by using the enterprise architect. So in your lab, what you will do is to pick one, pick up some classes and put them into the detailed design level, which means you have the attribute and operations, and then you can draw the sequence diagram. Then I will show you how to do that. Okay, so we first open this enterprise architect, and so you create this sequence view, and I showed you last week how to create the class view. And you can do the same thing. You right click on the model and you add a view and add a sequence view. And then under this sequence view, then you can add a block, for example, like a block site. Yeah. So this will give you add a new sequence diagram. Okay. So this one is empty. And then we go back to here, we see that the first operation is a child, open the web browser. So we know that the starter of this block is start with the kit. Okay, so you create a new actor here, you give this as a kit. And then the kit will enter this URL. So the kit must provide with some kind of user interface, and we can see this user interface is a children's interface. So this children is actually a boundary object. So here you create a boundary. So a boundary here. Here usually we don't give a name. We don't give a name. The reason is we will associate this object with the class. So I say this one is a boundary. Now it's a boundary. Now you will see that this one has a vertical line associated with it. However, this one doesn't show. We know this one is a children. Then we needed to associate this one with a children class. So what we do is you right click on this one. We go to the instance classifier. And then we choose which class this object associated with. So we're going to associate this one with children. So in order to associate this one with the children, you must already have the class diagram. So here, not this one. Block text here. So I already have the children. So in order to draw the sequence diagram, you must already have the class diagram in the detailed design library. Then I can associate this with children. And then the keys will send a message, and then what the message is sent to the children. So you double click on it, then you can choose the message is to enter URL. So why is enter URL pop up from here? Because if I go back to the class diagram, we see that this children has a enter URL, and also since the children is a subclass of this user. This user has set category and a set URL. Of course, these two, I mean, it's not inherited by the children, but the we know when we do the coding, we won't uh, re-implement this set category and set URL in children. But from this UML diagram, we don't know that. Uh, so in here, when you choose the message, there's three things you can do: enter URL, set category, and set URL. In which enter URL is the one the children will implement, and the set category and the set URL is from the user, is from parent class, and that will be implemented by parents. By parents object. But still, in here, these three are available, and we only choose enter URL. So this shows that we enter URL, and then what the kids enter this URL, and eGov will take the URL and check. So we will check and an address and check the address database for category shows that URL belong to a block category, and then the eGov will block. So in here we know the next is to the browser is for the browser agent to get a URL and check the category. So we go back here. We know the next is the control object browser agent. Again, we don't give a name, but we associate this one with the browser agent. And then this message sent to the browser agent is to take the URL. So here you can just choose I take the URL. And then it will check the URL category. So if we go back here to check the URL, check the URL category is a URL manager. You have to check URL manager. So in here, URL manager obviously is a control object. So in here, I create another object. I don't give a name, but I associate this one with the URL manager. And this message we get this message you get is check URL. Okay. You check URL, and this URL manager will check against URL category. Shows that what categories you have. So it will send a message to this URL category, and here we notice URL category is an entity because it represents data. So the next is we have an entity object, and then we associate with the URL category. is it? Okay. URL category is a table. And then this message sent to here. Of course, you can imagine this one is a query. And this query is to check the category. Is to check the category is to check the category, and then it shows this URL belongs to a blocked category. And then when you check the database, when you check the table, it will return a value. So in here you have a return, but so here is a so this one so by default is a function call, but this one is not a function call, it's a return. It's a return message. So in here this way you can say that this one is a return. Yeah, you check this one is a return, and the value and the return value you can say is a blocked. Shows that this is blocked. So here we go back here, it belongs to a block category. So when you check this URL for category, it tells you is blocked. So once it's blocked, once this URL manager sense is blocked, and then it will take block action. In order to do that, this blocked URL object is created. So in here, we will create, so this URL manager will create a new object called blocked URL. So how do you do that? So in here, we just go in here, we choose a new lifeline, but we still don't give a name. Hold on. This, go back here. This block URL is a control object. It's a control object. So so here we choose a lifeline, and then the stereotype we choose a control. Okay, this is how we do it. If you don't choose anything, then it will be a box. Yeah. Remember in our example 2, we have an object not specified into any type, then it will be a box. However, if you give a stereotype as a control, then you will see the shape change. And then this message is not an ordinary message. This message is to create. So this first let's associate this one with blocked URL. But this blocked URL is not, does not exist from the very beginning. Only when this URL manager receives this blocked message, then this blocked URL object is created. So it's created after this message, and what should we do? So then we need to specify this message, and this message, the life cycle is new. Okay, so in here, for the message, you can not only set the message, you can not only set what kind of message you send, you can also specify if this message create a new object or is for the existing one. And then here you can also show that this message is synchronous or asynchronous, or so there's a lot of options you can configure this message. And this one is new. Now you'll see that this object comes here. It comes here. And then it will take Once this one is created, and this URL action will be taken. So either this URL manager call this URL action, or this method within here will call itself. So in here, let's try how this block URL call itself, and what message can be done. So to call itself, you click on this arrow, and then you come back. Then you turn and then come back. Let's see how we do. Okay. Then come back. Why is not come back? Makes it longer. You can make it longer, and then you keep drag it back. Okay, now it is. Yeah. Yeah. You make it longer, then you come back. Okay. So this shows that this one is a self message, and this self message is the URL action. We'll take the block action. Then you specify this message is the URL action. Why is it two URL action? Because if I go back to the if I go back to here, you'll see that this URL action will override the URL manager's URL action. So the class, so this shows that this block URL has access to two URL actions, but actually, this block URL will override the URL manager's URL action. So we choose one, but the thing is, this one doesn't tell which one is which. Uh, okay, it doesn't tell which URL action belongs to which object, but usually the bottom one is the one for yourself, and the one on top is for the parents. So here we choose the second one. Okay, now we send a self message to block. The next, if I go back here, block the site, and showing a warning message. So the warning message will be shown by the browser agent. So here I send a message to the browser agent, and this message is to display the warning message. Display message. Okay, so in here you see that we draw the sequence diagram for this operation, and then we see that how different objects involved and how the message and the send back and forth. In here we have three type of object involved: the boundary, control, and the entity. And then we have a return message, and I also show you how to create a new object, and how to specify how to connect object with this class. With the classifier. Okay, so I think this will help you to finish your lab. Your lab will do the same thing. First, you have the class diagram in the detailed design level, and then you draw the sequence diagram to illustrate one operations. Okay, I think that's it for the sequence diagram. Let's go to, so here is the sequence diagram. Yeah, it's the same as what I just showed you, how I come up with this one. So in your 10 project, your 10 project, when you do the presentation, I want to do the same thing. So you first show the class diagram, and then you explain that how you get this sequence diagram. You describe the process just like what I show you here. So that's, so in your presentation, you must be able to connect the sequence diagram with the class diagram. Okay, the next one is the deployment diagram, and the deployment diagram is to model the runtime architecture of the system. It will not only show the software, but also show the hardware as well. And the hardware will be showing as a node. So this is one example. So the node is usually the 3D node. It shows this hardware and how they communicate with each other. And then within the hardware, you show which we call the artifact. We show different artifacts. So of course, in this hardware, there's many artifacts involved. We only show that that is matter to our software. So the node is either is a hardware or software element and shows a 3D box shape. And the node can have a node instance. So an instance is very similar to a class and the object. So the node instance is like you have a general node like the server, and here you have one kind of specific server. And then since node can use to describe the hardware, then the hardware can come up with different stereotypes. So you can like the PC client, CD-ROM. So here you can assign this node to different stereotype. And the artifact. So artifact is a product of a software development process. So this one may include the source code, executable, the design document, test report, the prototype, and the user manual. So anything produced in the process of the software development considered as an artifact. So there's thousands of them. So what do we show in here in this deployment diagram is, depending on the purpose of deployment diagram, we only show the one that matter. Of course, this node contains like thousands of artifacts, but we only show the one that will represent your current purpose. Association is very similar to the class association. The node can have association. We call it a relationship between the node, and then this you can show the association with kind of a stereotype. You can add a label to show that what kind of relationship they have. Node as a container. So node can contain other elements like a component, artifact, or even other node. So think of one hardware may contain other hardware. So that's very common. So the node sometimes the node itself is quite big. This can be a container. Okay, so this is a deployment diagram, shows the runtime architecture of the software system. The next is component model. And this one illustrates the software component that we use to build a system. Usually the component model is in a higher level than class. So a component can be one class, may contain multiple classes. So usually the component model is in a higher level than the class diagram. So a model, a component is something like this. So a model can may also expose the interface. Is think about the component is like a black box. You don't know what's inside, but the component will provide what services provide. So this is a service we call interface. It shows that what methods are available to call. Of course, this method may belong to one class or different classes, but this is what exposed outside to the user. So usually the component and the deployment diagram they use together, used with the node, it shows that this component itself is considered an artifact. So it's very common to include the component in the deployment node. So the component model can also contain other information, contain the requirement, can contain also come out with a constraint. But from the surface, you cannot tell like this component is associated with certain requirement or has a certain constraint. But when you double click on this component, there's an interface for you to enter detailed information. So but on the surface, it's just like a use case diagram. When click on use cases, there's a bunch of information you need to enter. So similar for the component. On the surface it looks very simple, but when you double click on it, you can link this component to a lot of things, like a requirement. You can add a constraint, a precondition, postcondition, and the kind of constraint you have for the component. Scenarios, the component can also include the scenarios. The last is the requirement model. The requirement model is to describe the system requirement or feature as a visual model. So this is an example of the requirement diagram. So in previous lecture, we're talking about the requirement diagram. The requirement diagram used for the traceability. Used for the traceability. So from here, we know that one requirement has a relationship with the other requirement. So this shows that if one requirement is changed, then you know what other requirement item to look at. I mean the other requirement item may also be impacted by the change of one requirement. So here this traceability will allow us to have a complete requirement one item is changed. And also this requirement item, this requirement diagram will enable us to not just changing the requirement. We trace change of requirement. We can also trace to the change of the component. Remember in this component diagram, when you double click on the component diagram, it will show like what requirement being attached to this component. So if one component is changed, then I know certain requirements being changed, and then I also can check the related other requirements. So this, you can see that once we have these diagrams, we connect all the requirements together, then we know that for any reason, either the requirement itself being changed, or this, what a component related to this requirement being changed, or like the classes connected to the certain requirement being changed, then we know what other to look at. So this traceability is a key. It's very handy, and this will avoid a lot of things like we change one thing and forgot to look at other things, and then the change may screw up with something else. But with this traceability, we can this will help us not just look at one single item, the related item to look at. The user interface diagram used to visually mock up the system user interface. So this one is very much like a virtual user interface, but when you click on the button or click on this checkbox, won't do anything, but will just give user a visual impact of what the interface looks like. And this does this make sense? Or do you want to change the font, or we want to regroup these items? So here, we'll give the user a chance to work with the user interface with you in the earlier phase. And then, of course, later on, once we settle this user interface, then we can use any programming language to come out with user interface. And then you click on this button, and then what going to be happen. And that's in the programming side. But before that, we have this user interface already negotiated with the customer. and we both sides agree. So this will eliminate the need in the future customer come back saying, okay, I don't like the interface. Can you just do certain things? That would be, that so that will cause a lot of actual work. So it's better to have a user interface diagram before we actually commit to the user interface. You use this when you show the customer, and then we can start from there. So almost all GUI element is available in the user interface diagram, the button, checkbox, combo box, state diagram, and so on. So anything you can think of in the GUI element is included in the user interface diagrams. By using enterprise architect, you can come up with any kind of user interface. Okay, now let's look at the lab. So this is lab 8. It's due on Thursday by midnight. So this one, the first task is to refine the class diagram in lab 7. In your lab 7, you have the class diagram in the analysis level. However, in order to draw the sequence diagram, you have to refine your class diagram by adding operations. Because operations is the message sending between the object in the sequence diagram. So without operations, you cannot send a message. So here, the first task is to refine and adding more operations. Adding operation into the class diagram, and it may also involve adding new classes. So that's up to you to refine your class diagram. The second is to draw a sequence diagram to illustrate the use case scenario in the lab 7. So here, the sequence diagram must contain boundary, control, and the entity, and each must associate with a class. And I already show you how to associate an object to a class by using the classifier. So that's what you need to do in here. And then please come up with a user interface diagram for the system GUI prototype. So here, please just come up with one GUI, okay? Because think about this, eGuard can have so many GUIs. I'm not asking you to have a complete GUI for everything. Just have one GUI. Yeah. For example, like the first page, or what the page for the parents to set up a category, or for the interface for the parents to like setting the time limits. So yeah, things like that. Okay, now let's go back to your term project. So after the meeting exam, and some student contacted me saying that didn't do well in the meeting exam. If there's any way to improve the grade. So here I will give you the opportunity in the term project to get some bonus points. So here I add the bonus point up to 10 points. So this term project is about 10 points. And this will, if you can finish these 2 items, you will get additional 10 points. So the first one is all use cases are connected to one or more requirement items. In here, when you draw the use case diagram, I ask you to enter the scenarios, how to add the scenarios and the precondition after, the post condition. But I didn't ask you to connect use case to any requirement items or create the new requirement items within the use case. So in here, if all the use cases you have here, 15 to 20 use cases, are connected to one or more requirement items, then you will get a 5 point. So in order to do that, there's 2 ways to do that. Let me show you. So there's many ways to generate the requirement items. One is directly from the requirement diagrams. So here you can create a view. There can be any view. Then you create a new requirement model. So the requirement model, so let me see how to do that. Let me show you. Let me first delete this one. Okay. And then in here you can just add diagram, and this diagram is in the extent. Then you can create requirement diagrams. Okay. Once you have the requirement diagram, then you can add the requirement items. For example, I can have a functional. Okay. You can add the functional requirement, give the description here, and so on. And so this is one way to do that. To create a new requirement item. And the second way is for the use case diagram. For example, here I have a use case diagram, and then you double click on the use case. And then here you can have a requirement. Then you can add a new requirement. Yeah, you can give a name of the requirement. Is the requirement, for example, like a requirement 1.5 or something like that. And then you give the description. Okay, the EGOT should allow parents to set time limit, something like that. Okay, so here you can create one requirement, and so in here, this use case is tied to this requirement items. And of course, this requirement item is not exist, so it's new. You can save. It's a new requirement. And then if this use case connected to more than one requirement items, you can add a new one. And then requirement 2.5, for example. So where you get this number from, remember that you have in your report, you're going to have all the functional and the non-functional requirements. In your report, you have a requirement 1.1, 1.2, 1.3, something like you have a label of every requirement items. So whatever you have in your requirement document, in your report, and then you put in here. You connect your use case to the requirement item you have in your report. So this is the two ways to create requirement items, either directly into the use case, or you can, from your requirement diagrams, you can also create requirement items. So in summary, if all use cases you have 15, 20 use cases, all use cases you have is connected to one or more requirement items, you get a five point bonus. And then for the class diagram, remember in our class diagram, I only ask you to draw the analysis level, and only for the classes that involve in the sequence and the state diagram, you have to, put more detailed information in there. For the sequence diagram, you need to add the operations, and for the state diagram, you will not just add operations, but also add attribute to describe the state. So some classes in your class diagram are already in detailed design level, but for the rest of them still in the analysis level. However, if you can have all classes in your class diagram are in detailed design level, then you will have 5 additional points as a bonus. Okay, so here I give you the opportunity in your term project to make up some point in your midterm exam. If you already did very well in your midterm exam, and then if you finish this bonus point, and this will give you an opportunity to get A plus, still will improve your grade. Okay, I think that's it for today.